Hello viewers, we're now taking you through the story of O-level physics, and this video we're going to go through the topic of electrical current, charge and voltage. So this is under current electricity and is suitable for students in both senior 3 and senior 4. So the calculations under this topic of current electricity, they can be divided into 5 parts. The first part will be electric current, charge and potential difference or voltage. The second one will be arrangement of resistors in electrical circuits. The third one will be EMF and internal resistance of a cell, and the fourth will be electric energy and power, and lastly commercial electric energy. So all these topics will be covered in bits. So in this video we are going to concentrate on this first part of the calculations, and that will be electric current, charge and potential difference. So there are some terms which we need to know. One is electric current. So I, capital I, is the symbol to denote current. So current is the rate of flow of charge, or to be specific, electrically charged particles, rate of flow of electrically charged particles. But even if you say rate of flow of charge, it is still okay. And the SI unit of current is an ampere. So the symbol for ampere, capital A, denotes the symbol ampere, and that ampere will be the SI unit of current. So each time they tell you to calculate current, after getting the value, you must remember to put the unit, and that unit is ampere. Now by definition, an ampere is the current flowing in a circuit when a charge of 1 coulomb passes any point in the circuit in 1 second. So 1 second, that is time, and 1 coulomb, that is charge. So the charge should be 1 coulomb and the time taken should be 1 second. That means that mathematically we can say that current is equal to charge over time taken. That is one term. Another term is called electric charge. We have been using the word charge. So what is charge? Now charge, the symbol used to denote charge is capital Q. So some use capital Q, others use small q. Both are okay. So by definition, charge is the quantity of electricity that passes a given point in a conductor at a given time. And the SI unit, like we saw here, the SI unit of charge is coulomb, and the written as capital C. So a coulomb can be defined as the quantity of electric charge that passes a given point in a conductor when a steady current of 1 ampere flows in 1 second. So these definitions are needed. They will be vital when we are dealing with the calculations. So we are going to first define the terms which we will be using under this topic of current electricity, and after that we shall go to the main part, which is the calculations. So if a steady current I in amperes flows for a time t in seconds, the quantity of charge can be given as that. So remember this definition from current. We know that current is I and charge is Q and time taken is t. So when I rearrange, I'll come up with Q is equal to IT. Therefore, we can summarize it by saying that charge, if charge is in coulomb and current is in amperes and time taken is in seconds, it implies that charge will be equal to current times time taken. So we must begin with the SI unit. The charge should be in coulombs, current should be in amperes, and time should be in seconds. Sometimes they can give you seconds in hours. It means you have to convert them to seconds. They can give you time in hours, so you have to convert to seconds. So with those terms and that formula for charge, we can go through these questions. So question 1 came from UNEB 28, paper 1, question 32, and says a current of 6 ampere flows for 2 hours in a circuit. Calculate the quantity of electricity that flows in this time. So here what we know that I is 6 and T is 2 hours, but remember that time has to be converted to seconds. So to convert 2 hours to seconds, it will be 2 times 3, 600. Therefore, when I use the calculator, this I is 6, it was given here, and this 2 is here, so it was in hours. We have to convert to seconds by multiplying by 3600. So when you use the calculator, the whole of this will give you 43,200 coulomb, and that's what they wanted. It implies that the correct answer was part D. Then question 2 came from UNEB 1992, paper 1, question 9, and it says a current of 5 ampere flows through a given point in a circuit of 2 minutes. Calculate the quantity of charge, that is capital Q, that passes the point. So still we shall use the expression Q is equal to IT, and then we substitute for I, which is 5 ampere, then T. Now this T is in minutes. We convert to seconds by multiplying by 60. And when we multiply everything using a calculator, we shall come up with 600 coulomb. Meaning that also option D is the correct answer. Then question 3 came from UNEB 2014, paper 1, questions 47b, and says a charge of 40 coulomb flows through an ammeter in 20 seconds. Find the reading of the ammeter. Now here, what we need to remember is that an ammeter is an instrument used to measure current. So when they ask for the reading of the ammeter, it implies that they want the value of the current. So we have Q, which is 40, and we have T, which is 20 seconds, and I is what they want. So when you substitute for Q and for T, we remain with I as the only unknown. So what we do, we have to make it the subject. So I will be equal to 2 ampere, and that's what they wanted. Then question 4 came from UNEB 2007, paper 1, question 48b, and it says a charge of 180 coulomb flows through a lamp for 2 minutes. Find the electric current flowing through the lamp. So still here we have the charge and we have the time, but this time is in minutes, meaning we have to convert to seconds. So charge is that, time is 2 minutes, so to convert to seconds, we multiply by 60. Now here, it is only I, which is the only unknown, therefore make it the subject, and that will be the current they wanted. So far we have seen two terms. The first term was current, and second term was charge or electric charge. Now the third one is what we call potential difference. So this one can be written in short as P dot D to mean, and can be pronounced as PD. So potential difference is the work done in transferring a positive charge of 1 coulomb from one point to another in a circuit. So the charge has to be a positive charge. and should have a magnitude of 1 coulomb. So that work done in transferring a positive charge 1 coulomb from one point to another within the circuit is what we call potential difference. That mathematically you can say potential difference is equal to work done over charge. So whenever current flows, it does so because the electric potential at 2 points are different. So that's why the word difference comes in. Difference in potential or difference in electric potential. Therefore, if 2 points are at the same potential, then no current flows between those points. The SI unit of potential difference is given by volt, and it is capital V. The symbol is capital V. Now, what is a volt? By definition, a volt is the PD between 2 points in a circuit if the amount of work done to transfer a positive charge of 1 coulomb from one point to another is 1 joule. So that means that the SI unit, remember we said the SI unit of a PD is volt. That means that from this definition, even another unit for PD can be joules per coulomb. So any of these two is okay. You can either write volt or joules per coulomb. So term number 3 was potential difference. Now the fourth term is what we call electrical resistance. So this one is denoted by a symbol capital R. So capital R is for resistance. Somewhere we shall see small r, and to mean also something called internal resistance, but we shall see that in the next video. For now, let's know that capital R denotes resistance. And the electrical resistance of a conductor is the physical opposition to the flow of current through an electric conductor. So opposition resistance is about opposition, opposing the flow of current through a conductor. The SI unit of resistance is what we call an ohm, done by this symbol. And an ohm is defined as the resistance of a conductor through which a current of 1 ampere flows when the PD across it is 1 volt. So the PD has to be 1 volt and the current has to be 1 ampere for you to get an ohm. So mathematically, resistance is equal to potential difference divided by current. And this resistance is capital R, PD or potential difference is capital V, and current is capital I. Now if I rearrange, take this on this side, I'll come up with V equal to IR. So this expression is very, very vital. Previously we saw that Q is equal to IT. Now we have seen that V is equal to IR. So you can remember that if potential difference is in volts and current is in amperes and resistance is in ohms, it implies that potential difference is equal to current times resistance. So that expression is very vital. Now let's go through some of the questions so that we can easily master the expression. So question 1 came from UNEB 2010 paper 1 question 21, and it says figure 5 shows a voltmeter V connected across a conductor of resistance R. If the current through the conductor is 2.5 ampere, and the voltmeter reads 12.5 volts. Find the value of R. So this rectangle is a symbol to denote resistance. So this R is the resistance of this conductor. Then this V denotes a voltmeter. Now a voltmeter is an instrument which is used to measure PD. And in this case, they want the value of R. They have told us that the voltmeter connected across the conductor or resistance R, if the current through the conductor is 2.5 ampere, and the voltmeter is this. So this is the PD across the resistor, and it's the value of V, and this is the current, it is the value of I. So you shall remember that V is equal to IR. Then come and substitute for V and also for I. When you do that, you shall come up with this. V is here, I is here. Now R is the unknown, so we have to make it the subject. When we do that, we shall come up with R equal to 5 ohms. That means that C is the correct answer. So now we shall go to question 2, which came from UNEB 1995, paper 1, question 29, and says the voltage supply in a circuit in the circuit in figure 3 is, so we want the voltage supply, that is the PD. So in this circuit we have this resistance, but remember it is in kilo ohms. Then we have the current, which is in ampere. So you come and quote our formula, then we substitute. Now in substituting, you should remember that current should be in amperes, which is okay, and resistance must be in ohms, but this one is in kilo ohms. So what do we do? We have to multiply by 1000 to come up with 1000 ohms. So 1 kilo ohm is equal to 1000 ohms. That's why we are putting here 1000. So when you multiply, we shall come up with 250 volt. That means that option D is the correct answer. Then question 3 came from UNEB 2009, paper 1, question 29, and says calculate the charge which flows through a 600 ohm resistor when a PD of 20 volt is applied for 30 seconds across its ends. So we have a PD, which is V, we have time, which is 30 seconds, and we have the resistance, which is capital R, and they want the value of Q. So here what we shall do, we shall first remember this expression that V is equal to IR, then substitute for V, substitute for R, then make I the subject. Now that I've got I can quote the formula of Q equal to IT, then substitute for this I and substitute for this T. You'll come up with this as the charge they want. That means that option D is the correct answer. So I've not yet told you about the books available. So physics, you need two books. One has notes, this one has notes, work clear notes, worked examples, try questions and answers. And another one has topical questions from UNEB with their marking guides. So this one has questions and also marking guides. Marking guides means it has solutions, it has marking points, and it has comments. So these two books are very vital for you. And also for O-level, we have a topical questions ranging from 2020 up to 1987. So these three books, you really need them, and if you need a copy, you can contact the author on any of these two contacts. So with that, let's go to our next question, that is question 4, which came from UNEB 2016, paper 1, question 49b. It says that a 12 volt battery is connected to a 3 ohm resistor. Calculate the current flowing in the circuit. So 12 volt, this is voltage of PD, and this is R. So we shall first quote, then we shall substitute. For PD it is 12 and the resistance is 3. So next is make I the subject, and that will be the current they wanted. Then question 5 came from UNEB 2005, paper 1, question 43C, and it says, find the voltage across a 3 ohm resistor if a current of 4 ampere passes through it. So first of all, V is equal to IR, and we know current, we know resistance. So just substitute for current and for resistance, then we use a calculator to come up with the PD they want. Then question 6 came from UNEB 2015, paper 1, question 50C, and it says, a charge of 20 coulomb flows through a resistance of 5 ohm in 8 seconds. Find the potential difference across the resistance. So Q is equal to IT. So we know Q and we know T. That means that we can get the value of I and make I the subject to be 2.5. So now that we know I and we know R, we can get V. So V is equal to IR. Substitute for I, substitute for R. Use a calculator to come up with the voltage they want. So in this video, we have looked at 2 equations. One is Q is equal to IT and V is equal to IR. And I believe that you have mastered how these 2 equations are used. In the next video, we shall look at those other equations. So that brings us to the end of this video. Thanks for watching, and be reminded the next video will be on arrangement of resistors in an electrical circuit. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. And also, if you know of any student who's not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.